Welcome everyone, my name is Rajitha De Silva and I am presenting a method for improved feature matching in outdoor agriculture environments by integrating semantics into the key point descriptors. In this work, we try to address the problem of perceptual aliasing in vineyard environments, particularly due to the presence of repetitive structures such as vine trunks. Having these repetitive structures causing feature mismatches in the vineyard will lead to errors in downstream tasks such as relative pose estimation, visual localization and visual slam. And secondly, the appearance of a vineyard significantly change across months, leaving trunks as the only consistent objects that you can see over an extended period of time. This picture shows a representation of our vineyard, and in the first row, that is indicated by green arrows, the pictures were taken by pointing the robot towards the center of the vineyards, and you can see when the season or the time changed from March to September, the visibility of the surrounding features and landmarks significantly reduced. And on the second image, indicated by blue arrows, the pictures were taken from a robot pointed towards the edge of the vineyard, and when the months change from March to September, you can only see the trunks and also some parts of the buildings. So trunks and the buildings are the only consistent things that you can see when the time changes from March to September due to the growth of foliage. So we are trying to tackle this challenge as well in this work. So the method that we are presenting is called KSI, or Keypoint-Semantic integration, which is a module that you can integrate into a traditional feature matching pipeline. So as any feature matching pipeline, we start with a pair of images, and then we extract the features. The feature extraction could be classic extractors like Shift or learned extractors like Superpoint. And then we also do the panoptic segmentation of this image pair to extract semantic mask instances for each image, and then we look for the key points that are on these semantic instances, and for those key points that are on the semantic masks, we get the corresponding semantic mask and we use a semantic encoder to generate a semantic embedding which will represent the shape of the trunk and also the size and the location and things like that. And we use that semantic embedding to modulate the key point descriptor to enrich the descriptor with semantic information. So any key point on the background is unaltered, and then finally we merge the background key point set and also the modulated or enriched key point sets and match them using a single matcher instance. So the matcher could be something like super glue or light glue. So this is an example visualization of our method and how it improves the feature matching. On the right hand side, you can see a pair of images matched from the same place, but the top image is from March, the bottom image is from September. And you can see some of the key points are being matched to wrong places and wrong trunks because of the similarity or the perceptual aliasing that is there in the vineyard. And on the left hand side, you can see how it improves with our method by integrating the semantic information into the descriptors. So we test this method, particularly how well it matches the key points on these semantically significant areas like trunks and buildings. So the solid lines indicate the accuracy delivered by our method, and also the dotted line indicates the baselines. So you can see we have tested it with Superpoint and Shift feature extractors, and also with super glue and light glue feature matches. In all the combinations, we can see our method outperform the respective baseline, and also particularly in months like September and June, which are the most challenging scenarios, our method significantly outperforms the baselines. In here, we look at relative pose estimation, and the absolute pose error and the relative pose error are always below the baseline. And for visual localization, you can see the median translation error is always lesser than the baseline, and also recall at 0.5 meters, 1 meter and 5 meter are always above or equivalent to the baseline. We also present the semantic BLT dataset, which has vineyard specific objects for semantic segmentation. You can use it for your applications. Thank you very much.